So I'm going to hand over to Ross Maloney now, and he'll open the proceedings.
Thank you, Leah. And wow, you've changed that slide really quickly. Well done, you. So consequently, we're really extremely grateful to Dara and Raffaello, who are going to be our speakers. Following their speakers, we'll have a section where we'll be asking questions, and that can be to our speakers, but also to each other. This is deliberately, and as Leah said, I think this is our third or fourth, where LEEA is looking at ensuring that we talk about lifting, but in that vertical context, in that supply chain that we service, so that we can get into a little more detail, and both in terms of legislation requirements, but also what's happening in the marketplace. When we talk about the industry at its broadest, we talk about it at its most general, but actually the value in what we do as the experts is when we talk about the real detail. And so we're looking forward to hearing from Dara first. Before we throw the time to you, Dara, let me just remind you all that it's LiftX on October 5th and 6th. The two greatest days of the year are in Aberdeen, week after next. We look forward to seeing you. If you haven't booked your travel yet, you better do it quickly. I understand the sun's going to be shining in Aberdeen. That's not going to happen. But looking forward to seeing you at LiftX in Aberdeen. So, Dara, thank you for being here, and over to you.
Super. Thanks very much, Ross. Just sharing my screen there, guys. No, so now, can everybody see that?
Yes, great.
Super. And again, thanks, Ross, and to Leah and Adam for organising this. I know a lot of work went in the background here, so it's greatly appreciated. So as Ross correctly stated today, guys, I'm going to discuss kind of training requirements and the basic operations and the organising of examining equipment in the offshore wind turbines. I'll give a brief introduction to myself and ProLift, review the training requirements, give an overview of the equipment in the turbines that our engineers are expected to examine and repair if need be, and discuss the operation of the project in general. And as Ross and Leah stated, we'll take some questions at the end of Raffaello's presentation after myself then as well. So firstly, guys, my name is Dara Hickey. I'm the owner and managing director of ProLift Handling, along with my colleague David McElhenney. We're in business since 2013 and have offices in the UK and Ireland. And we're the largest supplier of lifting material height safe equipment in Ireland. Of course, all of our service engineers are LEEA trained in various aspects. And the reason we're talking here to you guys today is because we actually have a bit of experience in this industry. We've examined contracts with examining turbines on the land and also the offshore turbines in Arklow in Ireland then as well. So just kind of give you an idea, guys, we've 10 qualified service engineers, and out of those 10 service engineers, we've 4 engineers that are specifically trained for the turbine industry. So that's the kind of split that we have. And we'll possibly look at adding 1 or 2 more as the actual industry grows, which it is growing. But at the moment, we're getting it through with 4 engineers, which is doing us well enough. So now I'm going to go over the training requirements, guys. And the training requirements are very important. If people out there who are members of LEEA or on this on this call are thinking about entering into this sector, you know, the training requirements are pretty intense. They take up a good bit of time and lost revenue because while you're training, obviously you're not earning money then as well. So just want to give you an overview of what's involved, what courses are mandatory and what courses are manufacturer specific then as well. So first and foremost, guys, before we kind of get into the training itself, it's important to know what type of engineer should be actually expecting turbines, because there's no point in getting an engineer involved and then we find out that he's afraid of heights and you have to spend €20,000 on training. And it's happened. It might sound silly, but you know, from our experience, we're doing this about seven years now for the turbines. A fitter background or a trade background is ideal, whether it be electrician, hydraulics or fitter. And the reason for that is because there's some pretty technical products in the turbines, such as the service lifts, and they do require assembly, dismantling, inspections, repairs. So it's not just a general inspector that would examine chains and lifting accessories. Ideally, a fitter background is required. As I said, they can't be afraid of heights, guys. You're up 100 meters in the air and these things move. When you're on top of the turbine, they move at the top, you know, with the winds and stuff, and they have to move. And then you're climbing ladders 80 meters tall. So you have to be physically fit to do the job then as well. It might sound really obvious, but these are the questions you have to ask yourself. If you have a team of 10 engineers and you're thinking, right, one engineer should inspect it, go through these questions and see, find out kind of who will be the best after all of this. And they have to be comfortable around water, obviously, because it's a water training course. And good with training courses, whether it be online and fit to travel to, able to travel to Germany like our engineers have for the actual Zagres lifts. And then the last point, guys, is these turbines are sometimes in remote places. So your engineers have to be willing and available to stay overnight. Like I said, there's no point in spending 20,000 on training. Everything's great, but can't stay away this week, lads. It's not going to happen. So they're just the little things to look out for, what engineers should be trained. When I move on to the actual training, guys, it's the GWO training that we have to do that's really mandatory, and that's the Global Wind Organization. They're a bit like LEEA. They set the standards for a safer, more productive workplace, but specifically for the actual wind turbine sector. They're a non-profit body, and they're founded specifically for the industry itself. The standards are created by the industry for the industry, and that's very important because you have all stakeholders involved in the industry helping to push the standards. And that's the only way standards can improve the whole time, with real-time feedback from all the various stakeholders. And the members are they're global leading turbine manufacturers and the owners. The owners like whether it be the state bodies, then you have the manufacturers like Vestas, so to speak. They're all involved in this GWO, and basically they identify areas of concern and they try develop a course surrounding that to push the standards. So the mandatory courses, guys, we do the turbines ourselves, like I said, here in Ireland. And, there's about 5 days of training that's mandatory. And they're all GWO courses. So the first course you have is the GWO Sea Survival and Boat Transfer course, which is 1 day. And that basically goes over water safety. You'll be in a swimming pool. You'll learn how to deal with falling into the water, how you get out and stuff like this as well. Because I said, the sea can get pretty rough out there, and you're have to wear the right gear and stuff like that as well. So it's a priority that your guys are prepared for this. If something does go wrong, what do we do? You also have a manual handling course. I know all of our engineers have this, and people, it's a very basic course. However, we have to do the GWO specific manual handling course. You're lifting up stuff. There's a lot of lifts involved. You're in a cramped space in the turbine, so there's different risks and stuff associated with working in a turbine for manual handling. Also, a fire awareness course is required. It's a half day. And then we have a working a height course. And working a height is a big part of working in a turbine. You're using, not all these turbines have service lifts, so you're climbing up ladders, you're double landing onto lashing points, onto anchor points, and a lot of height safety stuff involved. So it's 1.5 days, that course itself. And then also a first aid course then as well. They're all mandatory courses. The course themselves have to be renewed every 2 years, and you get a slightly reduced rate for refresher courses, but the time itself, say for duration for the refresher course, isn't that large. So all in all, you're talking about 5 days, a total of €1,700, which isn't too bad. But then when you factor in your lost revenue for those 5 days for engineers as well, it really does add up in that regard then as well. So as I said, before we go and do the training and have everything, pay all the stuff, let's make sure that we have the right guys on that training moving forward then as well. That's an example of the certificate that we get, guys, then in relation to the courses. You'll have your the training provider, what type of course, completion date, and valid to and valid from then as well. And there's I think there's two training centres in Ireland. There's a good few around the UK, and there will be a growing industry as well. So we shouldn't be stuck for options. There's also, when I look at the mandatory courses, there's also manufacturer-specific training. And that depends on whether you're doing the inspections for the actual owner of the turbine or the maintenance management company who are managing the turbine itself. In our experience, we had to go to Halo Lifts in Germany. So we sent 4 engineers over there. I think the training costs around €10,000, but again, your lost revenue, your travel, your time, so all in all would have been around €40,000 with that factored in. Which again is pretty big money, and it takes a while to claw that back. So if you're doing this, you want to make sure you have, the medium-term contract in place, or you have security of having that work for the next few years then as well. There's also a tractile block stop training, and then a specific training for various lifeline manufacturers, such as latchway lifelines and ladder systems then as well. Other clients, guys, would kind of, you know, we do the fire extinguishers as well, but we're doing the lifting equipment, the lifting accessories and height safety. And then the other thing that requires a medical certificate for the engineers then as well, to make sure that they're fit and healthy. Like I said, it is a pretty strenuous job, climbing up ladders, 80 meters, and a lot of moving. So you have to make sure the guys are fit and healthy then as well. So in regards to the operation of the whole of the system, I mean, for a turbine itself, whether it be on land or offshore, there's a minimum of 2 service engineers required, and that's the minimum. Now, for some turbines, we can send in 3 or 4 guys. They can kind of blast it out in 2 or 3 hours, but the minimum is 2. And you must always have your mobile phone on you, and then also a backup, whether it be a man-down alarm or a walkie-talkie, so you can communicate if communication goes down. For the offshore turbines, we're normally escorted by the client contact. So we don't just land on the turbine by ourselves. So the boat will bring us out, and then our 2 engineers will get off along with another person. And sometimes they get off with a maintenance team for that client who has to do work on the turbine itself. So, you know, it's a very vague one, but we generally do 1 to 3 turbines per day. And it varies greatly because of the variable factors. And first and foremost is the condition of the assets. If we have to do a repair on site or we find a problem, we have to deal with it there and then. So that kind of prolongs the actual examination of the equipment in the turbine. Weather conditions. We could have got a lift out to the sea, out to the turbine, everything's great, but then something just changes and we actually can't get off the turbine for a few hours. The boat won't come out. So again, that has a serious consequence of how much equipment can be examined and the duration of the time it's taken then as well. The availability of boat. So when you bring the engineers out, about 60% of the time the boat will stay there, but they will get a call sometimes to go back and pick out another crew and bring them to another turbine. So sometimes your work is done in the turbine, everything's examined, you're ready to go, but there's no boat to bring you to the next turbine. And that has to be taken into consideration if you're pricing for this work or looking to get into the sector then as well. And then lastly, the age of the turbine itself. And we do the turbines of the offshore turbines of Wexford in Arklow. They're an old turbine. They're being decommissioned probably in 2 or 3 years. So they're 20 years old. They haven't got half the assets that the new turbines have. They're much taller and stuff then as well. But, you know, this is a growing sector. There will be a lot more offshore turbines coming on. Those new turbines will be larger, more powerful, and they'll have more assets on top of it in those actual turbines themselves. So they will take longer. And then finally, like I said, sometimes we have to wait for the client to finish their maintenance works until we can leave that turbine and go to the next turbine. So that just kind of gives you an overview of the amount of engineers required, things that can delay the examinations of the equipment within the turbine itself. And then we just kind of have the 7 steps for planning, really. So, you know, step 1, make sure all our risks are controlled, check for good conditions of all equipment. These are basics before any job. You know, we must have our certs for all the equipment we're going to use, our load cells must be calibrated, the basic stuff then. That's the same for the offshore turbines themselves. The key one here is plan activities in advance. You know, you can kind of get an idea of what weather's coming the next 3 or 4 days coming down the road. So our service manager who's booking in this work keeps an eye on the weather. He's in constant contact with our clients to book in some days. And there will be situations where you have 3 engineers booked up for the week, everything is good, but then the day before the week, you know, so everything's good on the Friday, come to Monday, the weather changes and that job is cancelled, and you have to find work for those other engineers then as well. And that's the reality of the situation, and it does happen, and it's kind of for reasons beyond our control, such as the weather itself then as well. Number 3, only authorized trained people, and that goes without saying. It's a very regulated industry. Your engineers have to be kind of up to speed. They have to have all the correct certifications. You have to have their certs on you. We give them access to the certs via an online portal then as well. And then you have to wear the right equipment, whether it be the kind of immersion suit, you have the life jackets, you have your walkie-talkies, and then you respect the rules during the transfer. You know, each boat will have their own specific rules, for they don't change too much. But then when you do your GWO course, they specialize in the actual transfer itself and what to watch out for and how to do the transfer then as well. A key one then as well, be familiar with the emergency response plan. That's massive. If the lift breaks down, what do we do? How do we get down there? What's our plan B? And these are all specific to the turbines themselves and the manufacturers. They don't differ too greatly, but each client will have different variations within that then as well. Test communication channels, like I said, a mobile phone is a mandatory along with the backup equipment, whether it be a walkie-talkie or a man-down alarm that you can talk to each other then as well. And then just to give you an idea, we cannot transfer if the wind is greater than 20 ms and if there's a lightning storm closer than 50 kilometers around. So, everything's going ahead, everything's good. We get to the actual turbine itself, and all of a sudden, the weather changes slightly, and they could be on the way home then as well. And again, that's the reality of the fact then also. So what equipment is examined in turbines? Well, there's a fair few different types of equipment. We have the service lift itself, which is probably the most technical equipment, whether it be a Halo or a Zag-Res lift. There's lots of ladders. There's safety lifelines, there's general height safety equipment, such as your harnesses, your lanyards, your retractable blockers and stuff like this as well. We have electrical chain hoists, gantry cranes, davit cranes and jib cranes. Then we have lifting accessories such as your shackles, your web slings, your chain slings, lifting points. And then probably the most popular item by far is the man riding anchor points, which are scattered all over the turbines as well. As I said, they're the kind of lifting and height safety equipment. We also do the fire and auxiliary equipment, first aid supplies, and the accumulators and pressure systems. Most clients, some clients do this themselves. It's good, in my experience, it's good to offer the whole lot, because what you want to alleviate away is the expense for the client, where somone goes on, does all the lifting equipment, accessories, and you have someone else come on to the first aid supplies, the auxiliary, the fire equipment, and the accumulators. So if possible, I think should put you in a better position if you offer all of those items to be examined, more so than just the lifting and height safety equipment then as well. That's a basic list of equipment in relation to one of the towers we did in Arklow. It's just a little snapshot of what's involved. We have a tower crane lever, we have 15-meter fall arrest block, a wire rope hoist, a Tyrrek, bow shackles, ladders. And just to give you an idea, out of that actual tower, there's 12 man riding lifting points and six lifting points. There are shackles, davits, ladders. But as I mentioned previously, these are old enough turbines that we do. So there's only about 40 assets, where with the new larger turbines, there could be anything from 100 to 140 assets. So that has to be kept in mind then as well. The turbines turbines respect to 20 years old. There's no service lifts on them, so this sometimes slows down the work. And you're up and down the ladder, so this is why health and physical fitness is very important for the service engineers. The modern turbine considerations, the Halo Zag-Res service lifts, they're the most technical product on the actual turbine itself. And if you're doing the lifting equipment, that falls as part of even those height safety equipment as well. You can't do one without the other. They won't send two different companies on to do this. These lifts need to be stripped, inspected, measured, and reassembled. They'll take 2 to 3 hours. That's if everything is good. Sometimes you'll find a problem that you have to deal with, and then that could take the whole day. There could be spare parts shipped out and stuff then as well. And like I said, it's 80 meters latchway ladder, and it must be inspected. And how you inspect the ladder is you actually climb up the ladder. You're harnessed on, obviously. You climb up. You check the rungs for deformation. You check the spacings and everything like that then as well. But it's a long way up, 80 meters, climb a ladder, inspecting it. So that can take up to an hour then as well. I mentioned previously the new turbines of 90 to 120, it's up to 140 assets really. So far more than the older offshore ones that we have. But I know for a fact the newer offshore ones that will be coming over the next few years, they will have that amount of assets then as well. So it's going to take longer to do the actual examinations. That's just a breakdown of the modern turbines that we do on land. Like I said, there's no ones there on the offshore at the moment, but there's 72 fall arrest anchor points. I mean, that itself takes quite a while to do. All the new turbines have service lifts then also. But with the service lift, guys, you examine the lift, you do the maintenance, but you also have to inspect the structure of the service that goes on, whether it be the ladder or the ropes and stuff then as well. So again, even if the service lift, you have to climb these to make sure everything is okay. So just because it's service, it doesn't necessarily mean that the job is quicker. And we first aid kits, lifting bags, fire extinguishers. So the same type of equipment as the offshore turbines with less assets, but just more quantity up and down as well. I just kind of want to give you an overview of the service lift themselves and what to look out for. So this is the general checklist we have. We checked the hoist general, the housing, the engine brake, the centrifuge brake, the key configuration brake, the bearings, the rope guide. And this goes back to my point where a kind of a fitter or a trade associated service engineer, I think, is required, because you're dealing with hydraulics, you're dealing with kind of electrical as well. There's a good few moving parts. So that's why I think a fitter or trade background is essential for doing these actual examinations. I just want to show you guys a short video on doing the actual lift. No, sorry guys, just want to give you a quick overview of how the actual lift works, what to look out for, to show you the type of, what type of service engineer is required, to give you kind of a basic grasp of that then as well. Critical to any turbine, especially offshore, is what to do when an item is failed or repaired and stuff as well. So basically, communication is key with the client. If something isn't right, they have to know straight away. Especially kind of what is the safety critical, immediate action required, or can you wait 2 months to get a part and stuff then as well. But that goes with any lifting equipment inspection job, but with offshore turbines, it really is essential. So just to summarize, I took a bigger time, and I know Raphael has a great presentation to go through now as well, but there's massive growth predicted in the UK and Ireland for offshore wind turbines over the next decade. I think they're looking to subsidise 10% of the EU's power, which is massive. So there's huge opportunity there. The great thing is, at the moment, it's a quality orientated sector, which pays well. There's good equipment being used, good guys in the industry. Let's hope it stays that way. The concerns, like I mentioned already, guys, service can be cancelled short notice. Cost of training is expensive, along with lost revenue. And it only becomes viable for you as a business to examine these turbines if you have some contracts in place for the medium term then as well. And like I said, a specific service engineer is required. But all in all, guys, I think it's a very exciting industry, massive growth potential, and if you have the right people for the job. And I'm going to hand you over to Raphael now, who has a great presentation from PWAG, and he'll go over some a much better presentation I have anyway. Thank you. Sorry guys, 1 sec.
Ross, did you want to introduce the next speaker?
I can do that. I thought Dara had done it. Dara, thank you for that presentation. Whenever anybody talks about going 80 meters in the air, I'm glad that I sit in an office for a living. Raffaella, we're ready for you. If you're ready, if you want to share your slides.
Thank you. I am. Let me share the screen. Hope you can see it all right.
Great, thank you.
Okay, great. So good morning, everyone. My name is Raffaello Marino, and I'm responsible for the renewable energy sector in the PIVAC group. So PIVAC is a global market leader in manufacturing and the distribution of premium quality lifting and lashing products, serving a variety of industries. So part of my responsibilities involve visiting wind turbines production and deployment sites worldwide, performing on-site safety inspection and recommending the best lifting and lashing equipment to use in any situation. I'm just gonna move on. Today we're gonna look at the global wind energy market and any specific requirements in terms of lifting and lashing equipment needed throughout the wind turbine lifespan, from production to decommissioning. I reckon that this would complement very well the pretty detailed information that Dara provided us with, and will give you a more general overview of what sort of lifting and lashing equipment is used throughout all the lifespan of a turbine. I wanted to, for some of you, this information might be already known and clear. I just wanted to give a general overview on the technology we're talking about, just to create a baseline for what we're going to discuss afterwards. In general, a wind turbine is just a machine transform the kinetic energy of the wind into mechanical electrical energy. So wind turbines consist of foundation, a rotor, a tower, otherwise called also monopile. This word will come later on, again useful, and we're going to talk about that again later, and a shell and a rotor, we said it before. The foundation, of course, prevents the turbine from falling over. The tower holds up the rotor, and a nacelle or box. The nacelle contains large primary components such as the main axle, gearbox, generator, transformer, and control system. So the rotor is made up of the plates of the hub, which holds them into position as they turn. Most commercial wind turbines have 3 rotor blades. The length of the blades can be more than 60 meters. That depends. I mean, the technology is growing so fast that we are looking at very fast, very big turbines right now installed worldwide. In general, the average turbine is 1.5 megawatt and 8 of 80 meters, as Dara was saying before. Just to give you an idea about the weight of each single component, that is important, especially for manufacturers like us of lifting equipment, because we kind of think in terms of weight. So just to give you an idea, rotor assembly, blades and hub together, combined together, the weight account for about 22,000 kilograms, otherwise 48,000 pounds. The nacelle, which contains the generator, weighs about 52 tons or 115,000 pounds. The concrete base for the tower is basically based on concrete, again, weighs about 26,000 kilograms, and a lot of reinforcing steel. So moving on a little bit faster, I just wanted to share with you the information regarding the composition of the wind turbines. We're all familiar with the concept. So there's 2 different kind of mains, mostly different kind of turbines, onshore and offshore. To summarize these pictures, basically the turbines are made mostly of steel. That's important because the equipment we use are intended to be used in combination with steel, which is the main material used in both options. I want to now dedicate some time just to discuss the general market. As Darek said, it's a gigantic market. It's fast growing, and the projection indicates that it will definitely double in size. But basically, globally, wind power generated about 6.6% of the world electricity in 2021, up from 3.5 of 2015. So basically, that was when the Paris Agreement was signed. This makes the wind energy the fast growing source of electricity after solar. The 93.6 gigawatt of new installations in 2021 basically brought the global cumulative wind power capacity up to 837 gigawatt, showing a year-over-year growth of about 12%. Europe remains the biggest wind energy market. New installations amounted to about 17.4 gigawatt, 14 gigawatt were onshore and 3.5 offshore. As permitting bottleneck, global supply chain issues continue to delay the commission of new farms. Onshore wind made up of 81% of new installations, while offshore wind made out of 90% of new installations, following basically the same path. To summarize this information, the global goal that we set ourselves is to reach about 8,000 gigawatt of installed wind capacity worldwide by 2050. With this trend of growth, we possibly might reach this goal, but at least the short time projections indicate that the overall market will double in size within the next 2 years, which is astonishing. Next slide depicts perhaps is the most important one, and that's why I will later on will do a summary, and we'll go again. We're gonna look again into these slides, but basically it's a summary of all the relevant industry requirements. All the equipment is being used throughout the lifespan. So from the moment that the turbine is produced and put together, then it's transport, it's installed, then the stage of the maintenance, and later on the regeneration or dismantling. So the wind industry requirement when it comes down to lifting and latch application throughout the lifespan of a wind turbine. So basically, regardless it's on offshore, well, there's minor differences, but it's between 20 and 25 years, the lifespan of a wind turbine. So throughout the entire lifespan of wind turbine, each and every one of the stage. So a lot of different equipment is used. I wanted to draw your attention to the typology of articles that are used in terms of lifting and latching equipment. So lifting points, as we have seen from the previous slides from Darek, represent a good portion of the lifting equipment that is used inside those turbines. While during the production phase, later we're going to look a little bit in detail into this. I want to elaborate that. I basically prepared for each stage of the life of the turbine. I put together some pictures that depict the application, so that you really can see what article I'm talking about in what precise stage. But basically during the production stage, lifting points, grade 80, grade 100, grade 120 chains links are used, a lot of polyester links. Beams and trolleys can be used depending on the OEM. We are talking about special clamps, which we're going to look in detail later on, and most of all, also anchor points, because they are installed directly in the production. So the same anchor points that Darek team will inspect later on down the line of the turbine lifespan are first installed during the production phase. Then can be used stainless steel chain and fittings, depending on, let's say, the location where the fan or the turbine is bound to be installed, and shackles. Of course, comes without saying that during the transportation, a different kind of material is used depending on the type of transportation we're talking about. And mostly we supplied lifting points and lashing straps for nacelles and other components that were actually tied down on barges and from there loaded onto ships or brought to a different destination to the harbor. But mostly lifting point, lashing chains, and textile lashing straps are used during this application. Lifting points specifically are mostly of the lifting points adopted in this application are rotatable lifting points. Also, special spreader beams and special clamps and weld-on lashing points are used in this application. Tower installation is a different stage which requires much bigger equipment, and there's companies specialized in this particular stage, renting or selling to directly to the OEM, whether they take care of this particular stage, or in case they outsource it to a third party, they're equipped with very big cranes capable of lifting all these big components. In combination with those cranes, so under the hook, so to speak, we find a variety of other lifting equipment, among which lifting and lashing chains, spreader beams, lattices, and other kind of special beams that we are going to look later on in particular. For during the tower maintenance, as we said before, a lot of personal protection equipment is used, and also several lifting points, hoist and hoist chains. We, for instance, as PBAC, we actually manufacture the chain that is used in the hoist installed inside most of the turbines. Those hoists are used to lift up special bags made of textile, made of polyester, which basically they hold the whole equipment that is used throughout the inspection process. And now we're gonna, let's see time-wise how we're doing. We're going to quickly look at the nacelle and production process. So, I wanted to show you during specific process which articles I use, basically mirroring what we've seen in the previous table. So here you can see some pictures of 26 millimeters grade 10 chains links in combination with collecting links and shackles. In this case, are attached to the nacelle, and they've been used to handle and to handle this particular component throughout the production stage in the factory. Another article that is used extensively and during the production process is the lifting points. Here is an example of a special lifting points, which is rotatable. In this case, is a particular lifting point that can be removed very quickly, very easily. And these articles are used extensively during the production process, regardless which OEM or wind tower manufacturer we're talking about. More or less, with minor differences, these are the typical lifting equipment they use during the production process. Some more examples depending on which particular application. This is all the production stage. This particular plant is a plant that I visited in South America, and but I could see that this particular way of doing of using this lifting equipment is basically common to every turbine plant during the production process, regardless the location. it's always rotatable lifting points. They are used to the most. In this case, we see a variety of lifting points, so different kind of lifting points. I just wanted to give you a general overview, but mostly there are 3-4 models that are a common one across the OEM turbine manufacturers. So another article widely used for during the production process is the clamp, lifting clamp, which is by far the safest way of handling steel plates, which is a basic component. Later in the next slides, we'll see a little bit more in detail how the lifting clamps are used and what component I'm talking about. But basically, a combination of standard vertical clamp and standard horizontal clamps and special clamps are used to handle the big steel plates, which we know from before represent a big part of the clamp. So then we move to the monopile production process. So in the previous slides, we have seen the nacelle and the other components used at the top of the tower. For the base and the foundation, which represent a big part of it, we need to basically discuss separately. But that's called monopile, the foundation, and it's based up to steel. And it's important to say that more than 80% of the wind turbine currently installed on are based on monopile foundations, so basically of steel. So the monopile, just for your information, the monopile production market is concentrated in Europe and among few manufacturers. So lifting clamps is by far the safest choice to handle such steel parts. We're talking about, if we look at the picture here, the flanges are pretty thick. We're talking about thick plates, so we need special lifting clamps capable of opening the jaw enough to accommodate such thickness. I wanted to give you a few examples, like I did before, of the most common lifting clamps used during this stage are can be 30-35 tons capacity. The weight is pretty sizable because each one of these clamps can weigh up to 300 kilos. So we're talking about heavy equipment, but it's widely used during the production phase for the monopiles, in combination with the next kind of a lifting clamp, which in this case we manufacture specifically for one particular monopile producer, according to some specific requirements. So in this case, we were asked to manufacture something that could be operated by one single operator. So one single operator should be able to load and unload heavy pipes without leaving a safe position. That was one of the requirements, and we designed it in such a way that it's a very strong and a unique form of the design, which can be used in very limited spaces. And there was one of the requirements, for example, loading or unloading from boats or trucks. The design is pretty robust and needs to withstand and to meet all the toughest conditions. This was one of the requirements, and the clamp also needed to be open and balanced in position, so that was easy to place it onto the pipe. And of course, safety is the most important thing for us. So basically, the mechanism of the design of the clamps itself is designed in such a way that basically when the camel crawls and fixes up to the pipe without damaging the pipe, and can be safely handled. The design is scalable and adaptable, and of course, one important point, the price needed to be competitive. These are basically just one example, but it's the example of what are the general requirements for monopile manufacturers. So moving on, because otherwise we cross past the 50 minutes mark. Some example of lashing application. So basically, once the wind turbine is manufactured and assembled, before the the assembly, to move around some of the components, this kind of configuration is normally used across the turbine manufacturer, and regardless the location where we're talking about. big size lifting points are used, attached to the component in combination with the lashing chain links grade 10, grade 12, and lifting points attached to the track or the base. So normally those lifting points are the rotatable one. In this particular case, it's a special article which fits perfectly to this application. Moving on, for the logistic, when it comes down to the logistic and installations, I just wanted to give you an idea of what is being used normally. So we have to take into consideration that the average rotor diameters rose basically for 50% over the past 10 years. So the bigger, the better. That's the name of the game when it comes down to wind turbine. And so also the equipment capable of handling those particular components needed to grow accordingly. So in this particular case, we see lifting frames, particular one, that can really, it's a scalable design that can be adapted to any size. So in this case, we see a lattice beam assembly, about 150 tons, the length of 55 meters, which was attached to a big crane at the harbor. This example, I wanted to show you the lattice spreader, which is one of the type of spreaders that can be used because it's very lightweight in comparison to modular spreader beams and more cost efficient. So basically, it's a green choice, if we so to speak. Moving on quickly, another very critical component that is used during the installation, maintenance, and during the operations in general are the load monitoring equipment. The load monitoring equipment. Here I gave you just two examples of the most common one. So that's load link and load pins. Basically, the characteristic of those particular components is that it can be remotely checked, remotely controlled, and they provide an accurate and reliable load monitoring for lifting application. These are actually used across industries, not only in wind energy, but they are basically the same product suitable for all industry sectors such as marine, offshore, and subsea. Furthermore, we looked even before we directed the inspection and maintenance equipment use, so mostly personal protection equipment, anchorage points. We've seen actually one in the video from that before. They can be also used in stainless steel for installations close to the sea or on the sea. Some of the OEMs go for this option instead of the standard one. So stainless steel is normally a little bit more expensive, but the lifespan is a little bit longer. Going to the closing of my presentation, I just wanted to recap on the lashing lifting equipment, which I believe is the most precious, valuable information I can give you. So basically, to summarize, lifting points, chain links of different degrees, 80, 100, 120. I can guarantee you that the biggest wind turbine manufacturer, they privilege premium manufacturers, and with obviously with certificate and everything, so they privilege premium manufacturers. There is not really let's say a precise guideline when to use polyester links instead of steel, but both of them are used. So these are all basically the equipment that is used. While by all means this is not limited to what I show you, but in the limited time we had, I think we have a good overview. To wrap up my presentation, I just wanted to remind you a little bit, echoing what I said, that in general, as we said, the global wind turbine market, the production is bound to grow if you want to meet the requirements. So double in few years and 10 times the size by 2050. At the same time, the global wind turbine maintenance, repair, and overall MRO, what is called market, is expected to reach a value of about 232 billions in 2027 from the 81 in 2020. So registering once again a tremendous growth in a few years. Well, that basically concludes my presentation. So thank you for your attention.
Hello and welcome. I'm Trevor Hughes. I'm the lifting AP for Ørsted for offshore wind. Today I'm going to tell you about a journey which we started in 2020, where we reviewed our lifting operations and looked to achieve excellence. We did this by the following presentation I'm going to share with you. In 2020, we've done a review of our lifting operations. And as you can see from the images on the lower left, they weren't of any standard and of no planning at all. I'm going to play a little video for you to give you an insight to how lifting operations were conducted at the time. You can see in the video, the person on deck stands under the load is unbalanced, there's no high-vis clothing, and there's no communication between the slinger signaller and the crane operator, which results in time loss, extra CO2 being produced, and an increase in fuel being burnt by the vessel. So by optimizing the lifting operations, we save CO2, save on fuel, and save on time, which equals more production of the turbines. You can see there the land was just loaded anywhere they could due to the lack of communication. So what do we do now? For every lift we do, we create a lift plan, and every load is planned to be lifted to go offshore. We give guidance to how the lifting accessories and equipment should be used. Now I'm going to share a little video for you which we created to help our standardization journey throughout the business. Without lifting, operations can't work. You need to get maintenance tools, the oils, the greases up to the turbines. The only way they can get there is by going via the boats. They need to be lifted on the turbines.
We could be doing hundreds of lifts a day. Each one of them has the potential of a dropped object or some serious harm to people. So it's vital that our lifting operations are safe.
The dangers lay in many aspects. Biggest thing that can go wrong with a lift is it can fall on someone and they can be dead within 1 second flat. That's it. A hard hat's not going to save them. Being complacent is very dangerous and people can get seriously hurt if not killed.
Every lift can potentially be dangerous because it's falling from 20, 30 metres. It hasn't got to be heavy to go on deck, but when it comes down the force, it's going to be a lot heavier coming down. Even with just a small spanner and one bag could potentially kill someone.
The day of the incident, we had just been at a turbine and we had sent the packs up to the turbine, and we were doing the cargo, and there was a sling connected, which I didn't see because it was hidden. So exactly when the crane started lifting, I managed to step into the sling, and the sling took me up with the crane. I got a couple of meters up before they realized that I was also part of the cargo going up towards the turbine. Since I was kind of below the cargo, they couldn't really see me on the turbine when I was trying to signal them to stop. But then also the captain at the moment, he sounded a horn, and you know it was just a couple of seconds before they realized that something was wrong, and they took me down. So I guess it was more afterwards that you started thinking about what could have happened if say I would have, maybe I fell already on deck and I would have been caught up in my foot instead with my head towards the deck or something like that, or if I would have gone up 15 meters or 20 meters before something happened. Then you start to realize that it could have gone quite badly.
This work, if it's not done correctly, it can be deadly. There's no two ways about it. We've got what we class as routine lifts, where we use a fish box, where the item goes in the fish box with a closed lid, with a good centre of gravity with the lid closed. And we also have items which go in the lift bags, which need to be closed with a Velcro and not exceeding the safe working load of the bags.
Then we may have non-routine lifts, which are looked at by an AP, and he'll decide on which route it goes down to how they'll be lifted. So the danger within lifting, it's always there. The problem is when complacency comes in, and you're used to just lifting the same bags every day, and you think it's just the same in, same out, and it's when you stop doing the pre-user checks when the accidents can happen. The fish box lift, normally it could be heavy items like multiple drums of oil, which will get picked. It will be secured into the box so the load isn't shifting. It'll get taken at the quay side. They'll use 2 strops. Once we've carried out the pre-user checks, they need to be threaded through the fish box and then put in a choke hitch, opposite bites, and making sure the slings are moved to the centre of the box. It'll then be connected to the quayside crane, lifted up approximately 300mm, a pre-user check done, make sure the load's stable. We'll attach a tag line, then it can be slung off towards the vessel. So the things we're checking on a fish box lift, slings are okay, they're in test, there's no cuts or holes in the slings, and they're the right slings for the job. Normally 2 tonne, a minimum 4 metres or 5 metres. So once we've slung the load with the choke hitch and the slings are in the centre of the box, what we're aiming for is to have a sling angle of less than 90 degrees, because that's what the lift plan has been done to suit. The deckhand, who's now taken the role as slinger signaller, can instruct them to lower the load down towards the vessel, but on the outward side of the vessel. So once the load is lowered to handrail level, the deckhand stroke signaller will signal the load over the vessel deck, where it can then be lowered down to the deck. Then the deckhand will then detach the load and the crane can be parked away. So when an item's decided it's going to go in a bag, stores will pick the item, they'll weigh it, they'll find a bag which has a suitable safe working load. They'll do a pre-user check on it. They will then load the bags and make them available to go at the quayside for loading. Then we'll use what we call a set of brothers. We'll do a pre-user check on them, and then the bags can be clipped to the sets of brothers. One more check before the final lift's complete to the vessel. Once everybody's happy, then it can move to the vessel. So when we're doing a bag lift, we're doing our pre-user checks, and in that we're checking there's no tears or holes in the bag, we're checking it's in test, all the webbing's good, and once it's on the brothers, we're checking the hooks are out, and there's only 1 bag per hook. Once the vessel gets out to the wind farm, it'll push on the transition piece. The technicians will go up, do the pre-user checks on the davit crane. The technicians will crane down to the deckhand, who now takes the role of slinger signaller. Take it up, do a pre-user check, clear the handrail, take it away from the vessel, then it'll go up onto the transition piece.
Personal risk of getting hurt at your workplace. It is very easy to take shortcuts and, maybe not use the helmet because you're only going out and, doing a single lift. You do it once, or you're in a hurry. Usually it's then that injuries and accidents happen as well. That and stress, I think, is the most common grounds for injuries on board, and also, I guess, on the turbines and the platforms and so on. So to follow the procedures are basically to minimize your personal risk of getting hurt and getting injured.
There's a lot of changes been made recently to lifting operations. Take the time out to make sure you understand those procedures. If you can see improvements, put them in. Let's strive for operational excellence. That's what we want, and we can only do that with you.
So since the making of that video, we've actually changed a couple of things. We've upgraded the type of lifting brothers, and we've also removed the plastic loop out the taglines to comply with British standards, so there's no loops or knots in the tagline. So now I'm going to fast forward to 2020 to show you the improvements we've made. What you're seeing in this video is the fish box actually being lowered outward side of the vessel. So if anything was to fall, it would land in the sea and not on the person or the vessel. The tagline is now mandatory and added to every load. That's to allow the deckhand to be 1.5 meters minimum away from the load, as you've seen the person get it lifted up in the previous video. We've got the deck crew in high-vis clothing with good, clear, identified signals to the crane operator as well. So you may be familiar with the G+, the Global Offshore Wind Organization, and lifting operations is their highest and within their top 10 processes. And if you look at the pie chart, you'll see 56% of it is in operations. That's the main focus area. They also published this in 2022 and have highlighted the section everyday low complexity routine lifts. And that's what I've just been showing you there. It's not the people erecting the turbines, lifting the main components. It's when the technicians are offshore and they're lifting their daily service and maintenance tools and equipment. That's what's causing the main issues. And it's a bit of hearts and minds as well. It's upskilling the mindset and getting them people aware of why we need to change. That's the end of the presentation. I'd like to thank you for your time.
Let's move to some questions. We have some here. We've got a few moments to answer some questions. So the first is for Dara, and it's from Anthony Hope from Sparrows.
Yep.
Anthony asks, does the person who carries out the repair and maintenance activities on equipment perform the statutory inspection and or thorough examination too?
Yeah, from our point of view, we carry out the thorough examinations along the maintenance and repairs on the items itself then as well. So yeah, we do both. Some companies may require to split it depending on the manufacturer, where one company does examinations and the other company does repairs and maintenance on it. But we actually, in Ireland, we do both.
Great.
Yep.
A question from Ashley Gray, who asks, who chooses the assets that go in the wind turbine? That's for either of you.
Sorry, who chooses the asset that goes? Well, normally the OEMs, but normally the manufacturer itself. There's some common standard, sort of a basic requirements in terms of technical characteristics, safety, and so on, regulation. So that's why we see that, for instance, lifting points are used, just to give you an example, across the board, depending which OEM we're talking about. So the article might change, the size might change, but basically that's the kind of type of article that's used. So to go back, what kind of who chooses the assets? That's would be the OEM, in my opinion.
And I think the GWO kind of have a say in that to kind of evolve the industry and bring in kind of improve it the whole time with the assets. Like Raphael said, maybe instead of having a standardized man riding anchor point, maybe have a stainless steel one. So improvements are made within the organization and also.
Great, thank you. We have another question for you, Raffaello, from Anthony Hope from Sparrows once again, who asks, have you experienced any issues with the use of high-strength lifting equipment, G80, 100, 120, in the offshore wind industry in the form of hydrogen cracking and brittlement?
Okay, so if I understand correctly, sorry, can you rephrase the question? How do I explain the?
Have you experienced any issues with the use of
okay, with the hydrogen embrittlement? Well, I mean, that's an important topic. It's a very good question because obviously our application in the sea is prone to at least to subject some of the equipment to hydrogen embrittlement. Generally speaking, for instance, we tend not to use high grades steel alloys in a marine environment. So Just to give an example, DMV type approved elements that are being used in offshore environment normally are grade 80. So although we, for lifting applications, we sell and manufacture, for instance, during the production process, there is not such issue as hydrogen embrittlement. So we use widely up to 120 grade lifting equipment. Maybe during the deployment, if a chain is used or if a specific chain equipment is used, probably they will go for a grade 80 instead of grade 100. So to kind of limit the risks, the chances of hydrogen embrittlement. Although this happens across a period of time. So I don't know if I answered the question.
Raffaella, there's one more question for you, I believe. Is there an industry name for the wheel system that the monopiles were sat on?
Sorry, come again. Can you repeat it? I cannot.
Yeah. Is there an industry name for the wheel system that the monopiles were sat on?
That's not, I wouldn't say so, to be honest. And to be perfectly honest, we have a division of the company entirely dedicated to the lifting clamps and the monopile section. I cannot go too deep into that. So probably there is, but I'm not aware of it. So I'm sorry, I cannot talk to this.
And we have one more question from Anton van der Zelm from Royal Van Beest, Green Pin Shackles. And he asks, do you see any specific certification requirements for qualification of lifting accessories for this industry?
This is for me, this question?
I think that's for either. Whoever wants to.
Sure. I mean, of course, also shackles needs to have a specific, they need to respond. Also, in this case, we do not manufacture shackles, but I know because, of course, it's an important complement of an important element used throughout the production and the installation and the dismantling of the wind turbines. So definitely the shackles, based on my experience. For instance, okay, the Van Beest guy asked, what is it? I mean, Van Beest, for instance, is one of the Van Beest and another important manufacturer are the standard in this industry. So are the top manufacturers, and this, as far as I could see, in all deployments that I've seen, only high quality shackles are used, and all of them come with a precise certificate. So,
but yeah, there's no specific regulations or standards for equipment in offshore turbines. That may come in time through the working group GWO. However, they're just using stuff that's kind of used these elements like DNV and stuff like this then as well as a guideline, I'd say.
Yeah, sure. Of course, we should differentiate in which stage of the lifespan of the turbine, because obviously, if we're talking about the sea deployment is one thing, and during the production is different. But indeed, probably there will be some specific requirement also for the shackles.
Thank you. We are now at time, so I think we will leave the questions there. There's a couple more, but we will answer them after the webinar. Ross, did you want to just have a few closing words?
I didn't really, but I feel under pressure now.
Sorry.
So thank you, Dara, thank you, Raffaella, thank you, Leah, for fascinating. I love actually lifting up the bonnet and getting underneath what's going on in the real world. Thank you, everybody, for joining. And as Leah suggested, this will be up on our website, if not tomorrow, then certainly on Friday. Thank you all.
Thanks, guys.
Thank you.
Bye-bye.
Thank you. Bye.